Okay, one more example, probably our hardest example. I've already got the picture drawn here, but I'll go over it with you. A boy, he starts here. He walks 2 kilometres on a bearing of 90 degrees. So this here is 90 degrees, and he walks across here for 2 kilometres. He then stops, he changes direction. He walks 3 kilometres on a true bearing. Remember, true bearing is the bearing from north. So he walks 3 kilometres on a true bearing of 130 degrees. So I'm just going to go in the blue pen, hopefully, that the boy's gone here for 2 kilometres and then gone down here. This is where he started. This is where he finished. The first part of this question, how far east of the starting point is the boy? Okay, how far east is the distance from here across to here? That distance. Now we know that this part of it is 2. So if we construct from this blue line a right angled triangle and we find this distance here, we add it to the 2 and that is the total distance of how far east he is. So let's look at our right angled triangle that I constructed. We're trying to find this. That is 50 and that is 3. So we can now find out the value of x. We have got opposite and hypotenuse, so we use the sine ratio. So we say the sine of 50 is equal to the opposite over the hypotenuse, then 3 times by sine 50 equals x. If we work that out, 3 times by sine 50, then x is approximately 2.298133329. Rounding that off to 1 decimal place like it asked, x is approximately, so 1 decimal place 1, that is bigger than 5, so that rounds our 2 up here to a 3, approximately 2.3 kilometres. So how far east? The boy is, it's the 2.3, which is this distance here, plus the 2. So i.e. 4.3 kilometres east of his starting point. Okay, let's look at part B. Okay, with part B, same boy, he's walked the same way. He's gone 2 kilometres on a true bearing of 90 degrees, then turned 3 kilometres on a true bearing of 130. Part B is how far south of the starting point is the boy. So it wants, again, I'll do this one in red, it wants this distance here, how far south is. So our triangle, 50, 3, y. So we have got the adjacent side and we have got the hypotenuse. So we use the cos ratio. So we say the cos of 50 is equal to adjacent over hypotenuse. Then we say 3 times cos 50 gives us y, which is how far south he is. So 3 times cos 50 is the boy is approximately 1.928362829 kilometres south, 1 decimal place, 1, the one after is less than 5, so that leaves this 9 as a 9, also 1.9 kilometres. As a sentence, you would write, the boy is 1.9 kilometres south of his starting point. Okay, the third bit to this question is the hardest bit, and we'll go through that now. Okay, the third bit of this question says, what is the true bearing of P from Q? So from Q, if we draw our little compass, it wants to know what is the true bearing. So from north, it wants to know what that angle is. Now, one complete circle is 360. So if we can maybe find out what this angle here is, in here, we would then go 360 minus whatever we found out, and that will give us our true bearing. So let's look at how we can find out what this angle is here. I'm going to construct a right angle triangle. Okay, so that's P, that's E, that's Q, and I want to know this angle here. Let's call it alpha. What do I know? Well, I found y. Over in the question above, I found y, which was this distance here, and I found that that was 1.9. I also found out this distance here, P to E, which was equivalent to this distance here. I found that out in the first question that I did, and that was 4.3. So I can find the angle alpha. I've got opposite and I've got adjacent. So it's the tan ratio. So the tan of alpha is equal to opposite over adjacent. Then alpha is equal to inverse tan, opposite over adjacent. Putting that into my calculator, remember how I do that, is I go shift tan bracket 4.3 divided by 1.9 bracket equals, and I want to change that to degrees and minutes, so press my degrees. So initially I'll get 66.1612598, hit the degrees minutes, and that is 66 degrees 9 minutes 40.54 seconds. And if I round that off, let's say I round it off to the nearest minute, then that angle alpha is 66 degrees and 10 minutes. The reason 10, I look at my seconds, and that is greater than 30, so this 9 goes up to a 10. So that is that angle here. Remember, I'm asked for the true bearing. The true bearing is the distance from north. So it is that. Remember, one complete revolution is 360. So if I go, as mentioned here, 360 degrees minus 66 degrees 10 minutes, that will give me my true bearing. So 360 degrees minus 66 degrees and 10 minutes gives me my true bearing. That is 290, sorry, I haven't got that. It is 293 degrees and 50 minutes. Okay, so the question, the last bit of the question, what is the true bearing of P from Q? The true bearing of P from Q is 293 degrees and 50 minutes.